Over the last two class periods, we looked at fish kill day 6 and 7. So we've talked about solubility and we looked at solubility and temperature. So in the first part, you read about phosphates and nitrates and how they will impact the river. So think about runoff from farms. Those nitrates and phosphate fertilizers from the farms run into the waterways. And we want to know, is that what caused the fish kill? Like when we looked at the algae blooms in Florida, the Gulf of Mexico. We also read this and then watched the video on eutrophication. Then we looked at the effects of temperature on the solubility. So we took these points here, 1 through 4, and we plotted them on the graph. So what you'll do is you'll double click and you will use the shape tool. It has a circle and a square to draw the circles, which will come out like this. Then the line tool, you can click and you can draw a curve as well. Anything that is above that curve will start to solidify, so it is not fully soluble. Anything below is fully soluble. So for example, 140 grams is soluble at about 70 degrees Celsius. But if we were to increase the temperature for 140 to 80 degrees, it will also be soluble. Because this is 140, 80 degrees, it is still soluble over here on this line. So below is soluble, above is where it starts to solidify or crystallize. So you will use that graph. You're going to look at the graph to answer these questions. So in complete sentences, you'll write, according to the graph, 100 grams of potassium nitrate either will or will not dissolve. So at 40 degrees Celsius, you go up to 120, you go over to 40 degrees Celsius. So according to my graph, since that is above 40 degrees Celsius, it is not fully soluble at 40 degrees Celsius, 120 grams. For 120, it takes 65 degrees Celsius in order to be completely soluble. So you can use that as your explanation for 1. You'll continue and do the same for the rest. Then think of how does solubility affect temperature. So if temperature increases, are there more grams that can be dissolved or are there less grams as temperature increases? Temperature is increasing as you go to the right on your graph, and so grams are increasing as well. So use that to answer that question. For 6, this is asking you to look back at day 3 at the different plants. So farms, the aluminum smelting plant, coal power plant, and the sewage treatment plant. So it says list possible polluters that you see. So one thermal pollutant would be blank, and why. It'll mention that in the reading. How would thermal pollution affect the concentration of dissolved solids? So by increasing the water temperature with thermal pollution, is it going to increase your concentration of dissolved solids or is it going to decrease it in the water if you add temperature? Saturated solutions are where the maximum amount of solute is mixed in. So you stir it until no more can dissolve. Unsaturated is where it's pretty diluted. It can still hold more. You stir stuff in, it dissolves really quick, but you can still keep adding. Supersaturated is holding more solute than expected. So adding more sugar to boiling water, you can dissolve more sugar at the higher temperature than at just room water into just like plain or iced tea even. So less sugar will dissolve in iced tea versus hot tea. On the last part, you're going to open up a sim and record your concentrations. And it makes fun noises too. So on here we have, one of them is copper 2 chloride. What we need is for it to be saturated. So we can play with the two. One of them, you want to make sure they show values. And you'll adjust. So first you can adjust by adding solute. So this still has too much solution. It's not very concentrated yet. So once we've hit this point, it becomes saturated. So what you do is 1 mole divided by 0.228, and it will give you the molarity here. So this does the calculation for you on the right-hand side. So 4.35 molar. So there should be 2 decimals on all of them. You'll continue this. Potassium permanganate. That takes a lot less solute to become concentrated. Still saturated here. So this has a concentration or molarity of 0.5 molar. So that is what you're going to record, 0.50. Make sure you have the 0 before it in these boxes. So like 0.50 molar is how you'll write it. You can also put the moles and the liters if you would like to. What's on the left-hand side? Either one of those works. Then we have day 7, solubility and temperature as well. So this gives us some data from the river itself. So you look at this information and answer the questions. Which month had the highest river water temperature? So which month has the biggest number here? Which month had the lowest river water temperature? Same thing. How would the temperature affect solubility of dissolved solids? So if your temperature is colder, are there more or less dissolved solids? If it's warmer, more or less. So complete sentences in all of your boxes. Which month had the most rainfall, least rainfall? You'll list the month for those two. In which month would you expect to have more runoff? So runoff is from increased water. So which month would you expect to have more runoff from the fields into the river? So look at your rainfall and list 2 months for that one for 6. This month and this month, I would expect more runoff because of the amount of rainfall. Looking at your data up here. Continuing, in which months would you expect more dissolved solutes? So look at temperature, which months, this can be a larger range, anywhere from 3 to 5 months on there. Would you expect for there to be more dissolved solute and why? So tell me why you expect more to be dissolved using the information provided in the numbers above. Review the background information. In what month did the fish kill happen? So go to fish kill day 1, second paragraph. It will tell you this is the day that the fish kill happened and happened for several weeks after. So list when that occurred. What was the average water temperature and rainfall for the month and the month before? That is what is highlighted here. I've highlighted the month and month before. The water temperature was, for November, was 16.5 degrees Celsius, and the rainfall was 17.2 millimeters. So please list out both water temperature and rainfall for the month of the fish kill and the month prior. What would you expect farmland to look like during this month? So if it's colder, wintertime, what do you expect farmland to look like at that time? I would expect farmland to look like blank. And you can think of kind of, this is in Indiana, but like, what would you think it would look like with those temperatures? How do nitrates and phosphates generally cause fish kills? For this question, you're going to go all the way back up to the top, and it tells you what they do for fish kills. Don't tell me that the fish just die. Tell me kind of what is causing it. What's causing eutrophication? Why do the fish die? You can say like step 1, this happens. You can give me a sequence. Use this information here. You can also go to fish kill day 1 to the vocab of nitrates and phosphates and use that to answer the question as well. For right here for number 9. I've added a graph here for part 2. It wants you to use the temperatures provided. So for December, it was 14 degrees. November is 16.5. So you're going to read the numbers in grams on the right-hand side for ammonium nitrate and the same for ammonium phosphate. The question is, how many grams of ammonium nitrate could be dissolved at the time of the fish kill? This is before, at the time. So in December, what you can put, in December, about 165 grams of ammonium nitrate could be dissolved in 100 milliliters of water in December. This is equal to, so milligrams per liter, what you do is you times it by 10,000. So for example, for this one, it would be 1,650,000 milligrams per liter. You'll do the same thing for the other answers. 10B is looking at November on the first graph. 11A, 11B are looking at the second for ammonium phosphate. So December is red again, and purple is November. So where, and these are smaller, this is 0, 1, 2, 3, 4. These ones are going by 25s. So 25, 50, 75, 100, 125, 150. So use the graphs to figure out how many grams and then convert that to milligrams. You can also do, look up a conversion, converting from grams per milliliter to milligrams per liter, and you can convert your number into the answer for this one. So it'd be 2 sentences for each of those questions. Then you're going to compare those numbers here. So recommended maximum concentrations are 10 milligrams per liter and 0.1. So this is like $10.10. So for the first one, it's 1,650,000. Is that larger than the maximum or smaller? So at or above this shows in the table is significant algae growth. So with that in mind, if we have 1 million versus 10, could enough ammonium nitrate or ammonium phosphate dissolve in the river during the fish kill and the previous months? Yes or no, and why? So based on the data, I want you guys to include what numbers you get here for milligrams per liter and compare them here. Is it larger concentrations, smaller? Explain for 12. Then for 13, we're going to use a different set of data. So part 3, you use this data and from part 2. Part 4, you use table 3 instead. Does the data show concentrations above the recommended maximum during the month? So your maximum is 10 milligrams per liter. These ones, 0.13, 0.13, 0.14, are these above 10 milligrams or below? Phosphates, they need to be above 0.10. Please look very carefully at these to see if any of those exceed the maximum. So does the data show concentrations above the recommended maximum during the month? So look at these. Does it go above or no? Can nitrates and phosphates be ruled out as a cause of the fish kill? So based on this evidence, and your answer for 13, use some evidence, compare the maximum. So nitrates, the maximum is 10 milligrams per liter. So compare that to the highest on here, 0.14 milligrams per liter. And then phosphates is 0.1 milligrams per liter. Compare it to the highest on here is 0.1, and then the next highest is 0.02. So compare them. Is anything greater? So for 13, use that, and for 14, and use evidence and numbers to support your explanation. Lastly, what might have caused a small increase in concentrations on day 4, 5, and 10? So these are the ones highlighted in green, or 4, 5, and 10. They've increased by 0.01. So minimal increase. This is happening in December. So we know that increasing in concentration can come from one of 2 ways. One is there is increased solute. So if there's more runoff, there can be more solute in the river. Second, there can be increased temperature. So think in December, what would cause that to happen? And that is the end of your assignment.